We're going to see an example with simple regression where we have only one dependent variable, which is y, and one independent variable, x. In this example, as you can see, we have Carta, and they want to see if the maintenance cost of a bus depends on the age of the bus. So in this case, age is the one that's going to affect the maintenance cost. Age will be your independent variable x, and y will be your maintenance cost. Is the model valid? Test at 96% confidence. So we open our data. And we have age and cost. So we know that age is x, cost is y. Cost is given in annual cost in dollars, age is given in years. So first thing that we go is we go to the data tab, data analysis, and click on regression. Y range will be cost, X range will be age. Always remember to check on labels because we're showing labels. Confidence level. This confidence level is only for the question about estimating the population slope. So we're going to go through all the questions and look for the one that's referring to the population slope. So notice that here we have to estimate with 93% confidence the population value for the slope of age. That is the question that's asking for your confidence level. It's a confidence interval. So the value that I'm going to enter there is 93%. I do not care about all other confidence level that we're going to use. I'm just going to type 93. Where do you want your output to start? And then let's leave the rest. Click OK. And that's your regression output. I really don't care about the first line of the intercept and the last table except for the coefficient. The coefficient is where you get your equation values. So that's the only one that I'm really going to care. The rest, I usually just go and delete it for the first line so that I don't really get confused. Let me just decrease some of the decimals here so that we see it clear. Let me put the F in 2 decimals too. And then in the upper table, I'm going to put everything in 4 decimals just to have it all clean. Okay. Now, the first question is referring to testing for the model validity. In simple regression, you can really do it with 2 methods, either the ANOVA test or the t-test. Both methods should bring you to the same results. There are testing if beta 1 equals 0. So we're going to go is the model valid at 96%. 96 is 0.04 alpha, so notice that the hypothesis is just testing to see if the beta equals 0, if the beta is not equal 0. If beta equals 0, then that means that there's not going to be any relationship between x and y. That means that the coefficient of correlation is going to be also 0. So there is no point in answering any of the other questions. If you fail to reject this test, all you say is there is no relationship at all between x and y, in this case age of the bus and maintenance cost. But if we reject, then we can keep going. So we follow the ANOVA table where we have an F value of 54.75 and our P value equals 0. So we're going to reject HO at alpha equals 0.04 and the model is valid. We can keep going with the following questions. The next question is determine the regression equation. The regression equation is taken from the first column in the last table. That's where it says coefficients. Notice that we have the coefficient for the intercept, which is your B0, and then we have your coefficient for each of the variables, independent variables, in this case only one. So we start with H, which is B1. So that's B0 equals 220, B1 equals 131.67. And that's where your regression model comes from. Y hat, because that's the sample, equals 220 plus 131.67. Notice that we're following the sign here. If it was a negative, then we put a negative there. The next question, estimate with 93% confidence the population value for the slope. Remember that we indicated in Excel a confidence level. That is showing, the last table shows two different confidence intervals for the slope. 5% confidence, which is always the default value, and then it shows the second set of intervals is the 93%, the one that you specified at the beginning of the regression. And notice this one corresponds to H. So it's telling you that the 93% confidence level for the population slope, which is beta 1, is a value between 94.47 and 168.86. That's the value that we have here. The units of that is the Y units, which is dollars per year. So we are 93% confidence that the population value for the slope of H of the bus is between 94.47 and $168.86. Now notice that it's not even close to zero, so we're good. We're still having hope that it is a good model. If it is a good model, then we're going to use this equation to predict the maintenance cost based on the age of the bus. Then it says interpret the coefficients of the equation, and that is, what is 220? What is 131.67? That is exactly what we're doing. So we just keep our model in hand to analyze a little bit more the coefficients. And we start with the slope x1. So what is x1 coefficient? That would be B1. B1 equals 131.67. What does that mean? It's always for one additional unit of X, what happens to Y. In this case, for one additional year in the age of the bus, the maintenance cost will increase. Why increase? Because of the plus sign. Will increase by $131.67 per year. And then for the intercept, 220. What does 220 means? Well, we assign 0 to x1. If it is not interpretable, then all you can say is not interpretable. But if you say x equals 0, that means 0 years in a bus. Yes, it is interpretable. What it means is it's a brand new bus. So the maintenance cost for a brand new bus is estimated to be $220 per year. Now it's asking for the coefficient of determination. And we come here and we know that the coefficient of determination is r squared. There are two r squares. Well, remember we are in simple regression. In simple regression, we just use the regular r squared. In multiple regression, you're going to use adjusted r squared. But let's keep the r squared to be 87.25%. So that is 0.8725, which means that 87.25% of the variation in maintenance cost can be explained by the linear relationship between maintenance cost and age of the bus. In other words, you are explaining 87.25% of the variation in maintenance cost with the variation in your age of the bus. So it's a pretty good model just with one variable. Then let's look at the correlation coefficient, which is coming from where it says multiple r. So the multiple r is the correlation coefficient, and it's always this one. okay, for the simple regression, and that is 0.9341. Here's where you have to go back to the book and look into the diagram that helps you analyze the coefficient of correlation. In that diagram, you're going to see what values range that the coefficient of correlation range between -1 and 1, where -1 is a perfect negative relationship and 1 is a perfect positive relationship. A coefficient of correlation equals 0 is going to tell you that there is no relationship at all, and that is coming from figure 9.2. So in this case, if we place 0.934, it's getting very close to a perfect relationship. So we can say there is, and it's positive. Where do I know it's positive? Not because Excel gave you a positive value. That's not true. It is because H has a positive coefficient. That's where you get the sign for the R. Excel will always put it as positive. So you have to go back here and say, okay, this is positive, so it is a positive, very strong relationship. Those two need to be there. There is a very strong positive relationship between maintenance cost and age of the bus. And finally, the last three questions. Now that we have seen that the model is going to be a good fit, that it's going to be good to predict maintenance cost, then we have the prediction questions. Notice that those are the last three questions. But let's look at differences and similarities between them. Predict with 97% confidence the maintenance cost of a bus 72 months old. Predict with 96% confidence the maintenance of a cost of a bus 36 months old. These two are pretty much the same, except for the confidence level and the values given for your X. So those two values are the ones that are going to determine which one you use. So they're very similar really, and we'll see what the difference is. But look at the third question. The third question is going to be predict with 98% confidence the mean maintenance cost of all buses 6 years old. So 7 and 8 are going to predict one value. 9 is asking to predict the mean, and that's going to make a big difference. Why? Because we have a set of equations at the end of the template. Notice one is y equals y hat. What is y hat? Well, y hat is your regular regression equation, the one that we obtained in step number 3. So y hat is this equation. One of the questions will be answered just by replacing x with a given value of x, which we say x1g. That's the given value of x. So one is just replace x and you get your value. Another one is do this long equation that requires also y hat, and that is when they ask you to predict one particular point. And when the given value of x, which is x1, is not within the sample range, that means that the x value is not included in your sample. Notice that here we have values between 1 and 5. So if it is more than 6 years old, if they're asking for a bus that is 6 years old, then that's not included in the sample range. And that's where you have to use the long equation instead of just plugging in the values in your regression model. That's the first two questions, which are referring to one particular value. And then the last question is referring to the mean. That is always going to be by y bar. We already know that notation. Y bar is going to be for the mean. So notice that every time they ask to predict or estimate the mean, then you're going to use y bar. When they're asking for a particular point, a bus, then you have to go and get descriptive statistics for x and see if the given value of x is within the sample range. So the first thing that we do when you get to those questions is go to your data, go to data, data analysis, descriptive statistics, and get descriptive statistics for X. Click on labels. Where do I want my output? Let's say we have it here, and summary statistics. Notice that we have the minimum and the maximum values. Those are the ones that you need to check if it is included in the range. 72 months is very easy, and if you don't see it that easy, just 72 divided by 12. That's 6 years. Question number 7 is asking for what is the maintenance cost of a 6-year-old bus. Notice that the sample range is between 1 and 5. It's not including the 6. So that means for answering question number 7, we're not just going to get white hat. We're going to get the long equation. Okay? So that means that 6 years old, so notice that we transfer from months to years. We start getting white hot, but that's not our final answer. It will be our final answer if 6 is part of the minimum and the maximum of the sample. And then we run the equation. Again, where do we get all these values? They're asking for 97% confidence. So notice it has y hat, which you just obtained. Then it says t of alpha halves, comma, degrees of freedom. Well, that will be t inverse of alpha halves, 0.03 divided by 2, times 2, because it's a confidence interval and it's always a one tail, comma, where do I get degrees of freedom? Well, it's always going to be the degrees of freedom from the residuals. So notice that we use the residual degrees of freedom. That's how we get our t. Then it says times SE. That will be the standard error, which is given in your first table. SE equals 75.50. Then it says square root of, oops, I made a mistake here. Square root of 1, that might be a correction of the book, plus 1 divided by n. Notice that n is given as observations, that's your n, plus x1g. That is the given value of x that you are going to use to predict y. That was 6 years old. Minus x bar 1. All that is coming from descriptive statistics. That's the mean for x1. That's 3. Okay, 6 minus 3 squared divided by n minus 1. That will be 10 minus 1 times the variance for x1. Where do we get variance? We already know all these from descriptive statistics for x. And the sample variance equals 2 in this case. Okay, so let me just verify that we have it correct. And I'm having 6 here. So it will be this plus. Okay, that was fine. Then we get our t value, which is t inverse of alpha, comma, time divided by 2 times 2, comma, 8 degrees of freedom. 0.03, 8 degrees of freedom, that's 2.63. See, it's good checking. I might have made some mistakes. And then it's SE. So SE, you get it from here. And then times square root of 1, square root of 1 plus 1 divided by n plus x1g, which is 6, minus x bar squared divided by n minus 1, which is 9, times the variance for x. Okay, and because it's a simple regression, that's all we do. And then we get the multiplication of all that, t times se times the square root, and that minus this, that plus this. So notice that it is a value between 700, let's see if it is correct, we have here 247.56, and it is between 762.44 and $1257.56. So we are 90. Oh, here's where it is. It was what percentage? I used 93%. It's 97%. That's correct. So that's what the solution was wrong. It was using the wrong confidence. So 93% confidence that the mean maintenance cost of all buses